Here's warm-up number 21. First problem says write an equation in slope-intercept form. So slope-intercept form, that's y equals mx plus b. So that's the format I want my final answer in. Okay, and this is for a line that goes through these 2 points. So I always need the slope. So if it doesn't tell me the slope, it's gonna give me enough information to find the slope somehow. So here, since I have these 2 through points, I can use the slope formula. So the slope formula is going to be the difference of the y's over the difference of the x's. Okay, so if this is my first xy pair and this is the second one, then I can do -7 minus 3 in my numerator up top. And I can do 4 minus 2 in the denominator down below. And then I'll do the subtraction there. And -10 over 2 is -5. So my slope is going to be -5, okay? So now I've got the slope piece, but I still need the y-intercept, okay? And there's a couple of different ways that you can go about finding the y-intercept. What I'm going to do is think, okay, well, I know this is going to be in the form y equals -5x plus b, because I already figured out the slope, okay? So I still have to figure out what that b is. What I'm going to do now is I'm going to use one of the through points. It actually doesn't matter if you use 2, 3, or 4, -7. I'm going to use 2, 3 just because they're smaller numbers. Okay, but I'm going to plug that x and y into these 2 slots. So I'm going to put in 3 for y, and I'm going to put in 2 for x. Okay, and I'm still leaving this as b, but now I can solve for b. So I know it's going to be y equals -5x plus or minus something. Now I can figure out what that something is. So I've got 3 equals -10 plus b. Now to isolate the b, I'll add 10 to both sides, and b is going to be 13. So remember I said it was y equals -5x plus or minus something. Well, now I know what that something is, right? So it's y equals -5x plus 13. And that is my final answer. Okay. All right, the other 3 problems are all 3 2-column proofs. All 3 of them are 2-column proofs. They're very short ones, but they're meant to illustrate some things that get mixed up a lot. Okay, so looking at this statement, I've got, okay, these 2 angles are supplementary, and then these 2 angles are congruent, so they have the same measure. It really should say they're equal. The angles would be congruent, but the measures would be equal, but that's okay. All right, so if somehow we're getting that angles 3 and 2 are supplementary, okay? So if you look at the first statement, if you look at this piece, this is very similar to that, right? There's only one small difference, and that difference is right in here. So how could I change that measure of angle 1 into measure of angle 3? Well, I can do that because angles 1 and angle 3 are interchangeable, right? They're congruent angles, so their measures are equal. So what I can do is I can take angle 3 and substitute it into the first equation where the angle 1 was, right? So I'm taking that angle 3 and I'm replacing where the angle 1 was with angle 3. So this is substitution. Okay, now some people think that substitution and transitive are always interchangeable, but they're not here. You can't use transitive. Transitive is when you have 2 things equal to the same thing and then they're equal to each other. But that's not what happened here. We just replaced this one part of that first equation. So transitive doesn't work here. Okay? All right, so let's look at the next one. So this time I've got angle 1 is congruent to angle 2 and angle 2 is congruent to angle 3. So this time I do have 2 different angles that are congruent to the same angle, and that means they're going to be congruent to each other. So yes, you could use substitution, like in that first equation I can substitute angle 3 in for angle 2 since those are congruent. But this time you can also use transitive. So I think people see that substitution and transitive are often both options, and so I think some people don't understand the difference between them. They're not the same thing. Substitution is substituting in. Transitive is when you have 2 things equal to the same thing. They're equal to each other or congruent. Okay, and sometimes, yeah, you can use both, but on that first example, you can't. Okay? And then this last one, I've got, hey, those two angles are supplementary, these two angles are supplementary. And then it says angle 1 and angle 3 are congruent. Now, some people are going to say, oh, let's just use substitution or transitive, but those don't work here. Okay? The deal here, if you have, I've got this angle is supplementary to angle 2, and this angle is supplementary to angle 2. So let's just pretend angle 2 is 100 degrees, okay? Well, if got 100 degrees in both of those slots, both of these are going to have to come out to 80, right, to make this equation balance out. So that means when you've got two different angles that are supplementary to the same angle, they're going to be congruent to each other. But I can't just substitute into an equation or use transitive here. I don't have two things that are equal to each other. I have two things that are supplementary to the same angle. So this is an example of the congruent supplements theorem. Okay. You could actually do this in a longer proof using substitution, but just filling in the reasons, the only reasons that is going to work here is the congruent supplements theorem. Okay, and that's it for today. See you next time.